night, which I know most of you sent me emails and complained about it, saying this isn't fair. But we're going to talk about 3.5. This is relatively quick. This is on page 71 of your books if you wanted to follow along. So this is just basically talking about, remember when we were doing the normal CDF, or if I was graphing it, it was saying that the mean was 0 and the standard deviation was 1. Okay? But, oops, that is not a good normal curve. So there's no reason why we can't do this a little bit further. So if they were calling this 0, this 1, this 2, this 3, and -1, -2, -3, oops, trying to count. So that's what they're doing on the calculator, but there's no reason why we can't take the data that we already were given about normal CDF. So they have a problem, and this is actually, I was talking to Mr. Anderson the other day. This is actually real data about IQs. Okay, so it says IQs are normally distributed with a mean of 100. So the average person has an IQ of 100 and a standard deviation of 15. So it fluctuates out pretty far. He has another one that's the length of pregnancies. I can tell you that it is accurate information. Also heights. We did heights the other day. I think I did it as 2 inches because I didn't want to add 2.5 to everything. But a lot of those. But our normal distribution, if we are given the data, we don't have to have our mean as 0 and our standard deviation as 1. We can go ahead and do it where we plug in the information we know. So if I go to second distribute, and if I go to normal CDF, if we knew, if we wanted to know what percent of people have an IQ between, say, 88 and 117, just plug it upper and lower in, and then we know that they told us that the mean was 100 and the standard deviation was 15. So if you recall before, what we were doing is we were plugging 0 in for the mean because we were just doing the middle of it and going to the right or to the left. Okay? Now, are there people that are relatively intelligent? Yes. Are there people who are not so bright? Yes. And then everybody else in between. Okay? And, I could sit there and rip on, Ohio State and say they're obviously 3 standard deviations to the left, but I won't do that today. All right, so.
You're not salty today, sir?
Oh, you just Ohio State. I've never been a fan of Ohio State.
Yeah, I know, but are you salty, like really salty today?
No. Nah, it's whatever. So that's how it'll come up on our thing. And so this basically says with the information of an IQ between 88 and 117, you're talking about pretty close to 66% of your population. Is that a great deal? Well, we've all heard, oh, this person's a genius. Well, what classifies them as a genius? Is it because they developed something that everyone wants? Does that make them a genius? Or was there actually an intelligence level that took them over the top? What?
Sorry. I'm crying, Mom, because her daughter died.
What? Oh.
Why are we watching this?
Well, it was on the news because Astroworld. Another person died.
Who did?
Another person from the concert. Have you heard about it? No. There was a huge concert, and 8 people died at first because there was a crowd surge.
Really?
Yeah, and then the concert just went on for another hour.
Even though people had passed away.
Well, there were 50,000 people there, so they didn't even realize.
Where was this concert?
Houston.
In Houston.
It wasn't Rolling Loud, it was Astro.
It was 50,000 before.
People also surged the gates. It was more than 50,000 people.
Wow.
The people in the riot area, It was just like packed in.
They got
Like, there
squished.
was no way out,
Now the
but,
death toll is 9. I think it's gonna go up more.
Yikes.
That might be youngest victim.
That's no good.
Casualties, so people, like, how many people got hurt, but like,
Oh no, I thought 300 people got hurt.
Yeah.
Hundreds
yeah,
of people got
hurt.
9 people have died so far.
Confirmed by the police.
Huh.
Flame
Wow.
sicko mother.
yeah.
All right, so let's go back, and I'm going to change this. I'm going to change my window just so we can see it, and I think we can just change this to 0 and this to 1, and then it's going out 10 standard deviations. So, so if we were to talk about just IQs that we're using, if we go to the shade to the normal distribution, so they say the average person or the mean is 100 IQ. Okay, but let's say we wanted to see how many people are above that. So let's say we heard of, I don't know, let's pick somebody. Let's say Bill Gates. Probably pretty smart. He's got more money than the summation of like most of the people in the world. So I'd say Bill Gates is probably in the 120 area, but we can bring this up to like 200, for the upper. I mean, I've never heard of somebody having an IQ of 200. Is it possible? Maybe. I just have never heard of it. But then we know that we have the mean of 100 and the standard deviation of 15. So if we were to do something like this, we're looking for what percent of people would be above a 120 IQ. And I don't know if that's Bill Gates' IQ or not. I'm just picking an arbitrary number. If I hit enter and I hit draw, this hopefully should show up nicely for us. It does the calculation, and then it'll show us out to 10 standard deviations out. Oh, I know what I did. Oh, silly stirrup. I'm going to change the window. All right, so I'm going to change the X. Man, we'll go for perhaps 80 to 300. And if I graph that, that should work for us. At least I thought it would. Nope. I have to go back through, go through the standard distribute, draw, shade norm. We're saying above 120 up to 200. With this being 100, I'm just curious how this would work. Standard deviation of 15. I'm just trying to see if I can make it work. Maybe I can. I don't know. The reason that it didn't show is I think it didn't show because I was still centered about the average. Let's see if this works. Oh, I see kind of a blue. Huh. Still thinking the yellow's spinning. All right, so I can't really see it, but it does say that 0.09121 or 9.1% of the population would have a IQ above 120. Okay, so obviously as you go out to your tails of your normal distribution, you're talking about a smaller and smaller and smaller amount of people. So let's have fun, see if we can figure this out. Clearly that's not going to work for us as well as I wanted it to, but that's okay. Let's talk about, do me a favor. Will you use your phones? Those are the devices that are always in your pockets and you never look at ever. Find out for me from our friend Google or whatever search engine we use, what is the longest human pregnancy in days? Longest
The longest ever, the longest average.
ever.
375 days.
375? All right.
I hope not. That sounds terrible.
Over a year.
So,
Over a year. Oh my God.
Yeah, that's not normal. So there's some things we could do about this. We could just say, hey, let's just take a look at the z-score of it, which is the observed minus the mean over the standard deviation. So you said 375. Holy moly guacamole.
The average is 260.
Yeah, they came in 268 over a standard deviation of 15. So 375 minus 268. 375 minus 268, and it was divided by standard deviation of 15. So that's over 7 standard deviations to the right of the average. Okay? So that is extremely unlikely of ever happening. But if we went, we used our normal distribution, I'm not going to draw it, normal CDF. If we went our minimum of 375 to, say, 500, okay, which if you're pregnant for 500 days, that's a lot. Not sure if you know that or not. So they say that the average is 268 and the standard deviation is 15. So this is just going to give us the number. It's not actually going to graph it for us. Okay, so, oh my gosh, that's,
A big number.
so
Oh, yeah, a small number.
that was to the 13th. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Round it up. Okay, if I wanted to make this a true percent, I would bring the decimal twice in. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the likelihood that somebody gave birth, first off, this is like 7.1. That's our z-score. Okay, that is unbelievable. That's the percent chance that somebody would have that length of a birth again, or length of being pregnant again, or longer. Okay? Extremely unlikely. What did it say? You said the woman was really old?
Yeah.
She was like in her 50s.
She looked like she was in her 60s.
She's 25.
She's 25?
No fucking way. Look at these wrinkles. No fucking way, she's not 25.
Hey, watch the language I'm recording.
Sorry.
Wait.
No wonder why YouTube keeps flagging my videos.
Yeah, when was this?
1945. And World War II.
1945, yeah.
Stress, I guess. I don't know.
1945.
Wow.
Yes, stress made this lady be pregnant for 375
Maybe
days.
didn't want to.
Wow.
That's valid.
Does it say how big the baby was?
It was literally a normal size baby.
48 pounds?
No,
Right?
it's
Yeah.
like a normal.
1.4 kilograms. So,
Oh, that's like around.
I mean, that's normal.
it was in Los Angeles.
Pretty much.
Yeah, it's a normal baby.
Wow.
3 kilograms, like 6 pounds.
A few more wrinkles.
Yeah, multiplied by 2.2, yeah. Huh. Wow. Crazy. So there's definitely things, of course, the normal CDF works really well for you. So I want to give you all the opportunity to either work on this. It'll be due Monday, because today's Friday, right?
Yeah.
This will be due Monday, or, and then, so things I have planned. So this page 193, 194 is due Monday. I have then after that, I want to review on the Tuesday. I have a quiz on Wednesday. Yes, I'm giving a quiz on the shorter day, so I'll make sure it's shorter. Quiz on Wednesday next week. It'll be from 3:1 to 3:5.
Wait. 3-1 to 3-5?
Yeah.
No. Yeah, because we just took a quiz that was 3-1 to 3-3.
Yeah, now I'm adding 2 more sections.
Why?
It's only 4 questions.
What? 4 questions?
4. 2 on the front, 2 on the back.
Well, is it like 4 questions with like 7 cards each?
Mhm.
Like draw your curve and
It-
then put
it's-
in the
it's a-
command and then.
It's a front and a back. That's the best I could tell you.
So it is.
You probably have to draw what the curve looks like, so that's going to take up some space. You know, and then we'll get to it on Wednesday, and you're like, "There's 16 questions here, pal." Yeah, you know, Stirp's making stuff up.
What?
So
Please don't make stuff up.
I'm not making stuff up.
Well, you just said you might.
You know, I'm a